This is Super Duper Looper, and what he is he's the actual harmonic frequencies. We have two different types of harmonic frequencies. Well, we have many different types or sizes of it that you can make. The first one here, this harmonic series, is a much smaller version. It's just got it's 1 divided by, I can't fit him in there. This guy is just 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8. He's just this number divided by 1. And it gives us this harmonic series, harmonic pyramid here. But you see, it's got a lot. It keeps growing. It's not, and it's palindromed, and it's not just one straight harmonic series. What we want to end up with is a straight harmonic series. It's just ones and the 11s and the 3s all the way through to infinity. That's what we were really after, to figure out all the constants of the universe. So this one is the same thing, the same concept. It's 9801 now. As you can see the conformal invariance here. I've just got the numbers in the calculator, and you can see that all the processes are going through, and he's still maintaining the conformal invariance. And he'd be a great circle wave. He'd come up with some really neat stuff on them. I'll try to get a chance to run him, but it's really hard. It takes a lot of time to get any of this stuff done. So this wave is like him, except he's not. No, he's only Super Duper and he's Looper. So that's the difference. Now here we got 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 1, 2, 3, 4, 5, 6, 7, 17. So this one is, if you notice, he's twice as big. Again, he's just 1 divided by that gives you, and anything divided by this number or this number is going to set them onto the harmonic series pattern, but not the pure harmonic series pattern. Set them onto these patterns. We want to set them onto a pure harmonic series pattern. Now, this is a great mathematical feat that I've done here. It's not easy, and it wasn't easy to figure out. Now that I have it figured out, though, I can calculate super easy all kinds of stuff in the universe, different speeds of light, things that change, because as we get to very large sizes from very small sizes, there are changes in these constants, and there's always going to be a change in a constant. There's no such thing as a constant in an ever-changing universe. So we need to be able to track these changes so that our constants will still and will work no matter where we're at in the universe, what size or quantum or wherever we're at, the cosmos. We need to make sure those constants are still accurate. And they're not going to be accurate if we can't follow the change of the universe. This is like forcing a change. This isn't following the change of the universe. So what I did was I took this inverse of this number right here and the inverse of this number right here, and I divided them together. So there's two pyramids divided against each other. And since one's a 10 and one's a .0, we got basically multiplication, so we interfered the waves, and that's where we got that Super Duper Looper wave there's all those really neat things that I just showed you. So from here we get a frequency, this 99 right up here, this 999, I can't highlight it, but we get this frequency. Okay, now using that frequency I was able to make it bigger and bigger, and generate these next couple of things that you can see, these next waves. So as it got bigger, okay, the first thing, like here we have 36 nines in it, and it got bigger, and we can see quite a beautiful result came out of that, and you can see the number here. It's a big 99998. There's the 8 again, 90001. So I just expanded it out to 36 digits. Just literally, out of my head, just came up with trying to keep it on the harmonics, but and just tracking down this frequency, just following it, because it is a wave. So it has a it has an evolutionary path, and you can follow it. And that's what I'm doing. I'm following that our universal wave, our harmonic pattern. I'm following it, trying to get back or somewhere where I can get a good, clean pyramid out of it. So this really beautiful wave here, and there's no doubt. I mean, come on, there's a frequency. These are frequencies shooting across the numbers. I mean, this is the end of the discussion of whether or not these are waves or answers from the calculator. Okay, if you don't get it by now, you're not gonna, and you should just give up on everything. I mean, seriously, you're not. If you can't, if somehow your brain can't wrap around that this came out of the calculator, but it's a wave. And it's a real wave. This isn't a pretend wave. This is doing real wave things. It's doing real calculations. It can't do these things that you're looking at. This isn't an optical illusion. It's really processing, and it's really doing the processes it needs to provide you with these images, which is not an easy thing to do. It's a lot of math to provide these types of images and the conformal invariance. So this is you're looking at. I'm literally doing the most math that anyone's ever done in any theory, probably more than all of them combined. It's just that after a long time, I've learned how to get them done in the most simple way. And that's by using waves, just like everyone else uses waves for computers. We use them for communications. I use them for math, and because that's what they're for. They are information providers, and they can store information. They can use it in any way they want to. So I'm doing this math. Okay, so it is accredited to me. No one else is doing it, and it couldn't get done unless I knew exactly what frequencies would do what, and where to put them in, and how to run the math. And knowing that this type of math is going to give me certain results that I need. So that's a beautiful wave there. The next one that came up was, okay, so they're really big. So this one was even bigger, more nines, a bigger 9801. Now, when I talk about, I know that I'm doing the math, I'm not kidding. The reason this works is because I know something that no one else knows about mathematics. 9801 is the reciprocal to 1. 1 does have a reciprocal, and it is 9801. And I'm going to prove that mathematically in just a second. I've already proved it several times mathematically, but nobody seems to catch on. But this time I think it's going to be tough for them not to notice. Again, a wave, not an answer from a calculator. Very beautiful pattern. So I'm starting to see that I'm getting closer to what I want, because these are 1s and 2s, and I'm starting to get closer to like pure pyramid. As a matter of fact, on this next one, I hit it dead on. Now this is ends any discussion of waves or calculator, because this is my one wave. This is my pyramid of harmonics. Right here. There's we start. I get there. It's big. We start at 1, and then 11, 3. So you see the pyramid of harmonics. Now I'd like to think that I just drew that in there, right? Just stuck them in there, but I didn't. It's that's the calculation. It's actually this exact frequency, which I'll give you. Can't copy here because it's an image, but see the 98900. It's just exactly what I thought it was. I had to find the actual reciprocal to number 1, which I knew was 9801, but I knew that wasn't big enough to make this pyramid. So I had to track down the biggest one I could, and I found it. And it is indeed the reciprocal to number 1, because here is the reciprocal of that number of 9801. It is the 1s, the perfect pyramid of the 1s. Now, another thing that I want you to keep in mind here, this is absolute proof that this is a wave and not a number from the calculator, because there's nothing here in this answer from the calculator except for the wave. These other things in the background are zeros. They hold no value. They have nothing to do with anything. The only thing that came out of the calculator was this wave of the perfect harmonic series. There's nothing else. And he's spinning 360 degrees, so that doesn't hurt his credibility. And he's, of course, highlighting out numbers. But he has nothing to do with the background, all this stuff going on in the calculator, all these processes and stuff. It's nothing to do with him. He's sitting out here on the skin of the wave, um, being a wave. So this literally, I mean, that's absolute proof. No matter what anyone tells you, look at the wave. See it spreading out there, the wave. Absolute proof that I have made a wave and I've captured the collapse, because there's nothing else involved in this answer. Nothing other than this wave. And the other thing to notice is, as we're going down, this decimal point's up here, so we're getting smaller and smaller actually as we come down. But at the same time, the wave's expanding faster than we're getting smaller. And look, he's got light waves shooting through. So that's, in essence, I can't put it into words yet, but this is how we're expanding and shrinking at the same time. He's going down decimally smaller and smaller and smaller. I mean, he's tiny by the time he gets down here compared to up here. But yeah, he's also bigger because of his expansion. And it's very deep thought and hard to conceptualize, and I haven't been able to really wrap my head around it. I can just see it happening. So I know it's important. That's how this is done. That's how come we can have this inverse and this obverse relationship, but it's still hard to really conceptualize. That's a beautiful example. See, all these backgrounds that we saw in all the other waves, these are all processes that were happening inside of the calculator with the waves. Now these processes are still happening inside the calculator, but this wave has nothing to do with it. He's just out here on his own. He's not involved in the processes or anything in the calculator. That's the wave we produced when we did the reciprocal of 9801, which is the reciprocal to number 1. And that proves it, because you get 1 when you do that reciprocal, a very big one, but it's still just ones. But it's really neat, kind of like the Stairway to Heaven. When we see him over here, where we actually make him right here, and we actually divide him out here and make the ones. Close my computer, okay. Well, what's gonna be fun? Seriously? All right. Well, that was. So when we shrink him down, I like this look over here, because it's exactly what it should be. The Stairway to Heaven. And in mathematics, it's one of those things that we look for all the time, the Stairway to Heaven. And I think this is as close as we're ever going to find with the ones. Now remember, you can set any number onto this pyramid now. Now that we've discovered it, like this one is a stairway, but it's not number 1. I think it's the collapse wave. So I did 37. And that's what we got. See, 37 by that big 9801 divided by it, and we get this harmonic series perfectly all the way to infinity. So I've done it. I've accomplished my goal, solving the universe by using the number 1. But this is the solution. This is what all waves are propagating on. This is how you calculate every one of your constants. This is how you will understand the universe, through this wave. It is the basic foundation of the universe. It's the pilot wave. It's the harmonic pyramid of ones. It is the 1, 2, 3, 4, 5, 6, 7, 8, 9 wave, as I think I have here. Yeah, he made, when we ran 1, 2, 3, 5, 7, 8, 9, he came up, it ended up with this great big palindrome 1, 2, 3, 4, 5, 6, 7, 8, 9 when we ran the ones through it. So it is everything. It makes everything. So we really need to get this information out to people. And that's where you come in, because if you follow me and give me a like, that really helps a lot, because I'll get higher rankings in YouTube. More people will be able to see this, and we'll be able to get the financing and the other researchers involved. So please leave a comment, give me a like, and follow me. It does really make a huge difference in whether or not we can disseminate this information or not. Have a good day. Thank you for watching. Don't miss the next videos because I'll explain the X's and O's. A lot of really great waves that I can show next time because we don't have to explain the whole universe with them. And a lot more really interesting stuff coming up. So try to get on the channel and follow it, and you'll see what's coming. Thanks. Have a good day.